Okay, now we are going to look at LEPAK chapter 6, question 1b. We have in the question a coil having inductance of 0.140 Henry and resistance of 12 ohm is connected across a 110 volt and 25 hertz power supply. So, according to the information we have here, which is 110 volt with 25 hertz power supply, we can deduce that we have an AC supply, because for AC the current and voltage is going to alternate or change periodically with the angular frequency omega is equals to 2 pi f here. And we also have in our circuit an inductor and also resistor with the given value here. So basically our circuit has a coil, which inside the coil we has inductance and also resistance. So our coil, let's say this is the coil connected across an AC supply here. So this coil here now has both the resistance and also inductance in it. Okay, so to understand better this circuit, what am I going to do is I'm going to redraw the circuit by showing the component that is present in the coil, such as the resistance and also inductance separately. This is because for us to deduce that this is RL type circuit, both this inductance and also resistance are present inside the coil that has been connected across the AC supply. Our resistance is 12 ohm and inductance is 0.14, and the voltage here given 110 is basically our VRMS, because for the AC circuit, the first thing, if it is not mentioned V0, maka it is VRMS. And also always to identify a voltage in the supply, we refer to the voltage as a VRMS. Okay, so VRMS here is given as 110 volt with a frequency of 25 hertz. So these are the information we have here. So the first question here is to calculate the RMS current. So to calculate the RMS current and calculate and label the phase angle, basically the phi here, in the phasor diagram to show the phase relationship between the voltage and also current. So we have to also show the phase relationship here. And finally, to calculate the average power dissipated in the coil. Okay, to answer the first question here, which is the RMS current, we must first identify the type of circuit. As we have noticed that in this circuit we have resistor and inductor connected. Therefore, this is an RL circuit, where this type of circuit is called as combination circuit, where in the combination circuit we will have total opposition, which is called as impedance, to occur from the component that the circuit has been made up for, such as we have resistance and also inductance here. Therefore, this resistance and also the reactant of the inductance is going to cause the opposition. Okay, so to find the IRMS, we are going to apply the Ohm's law relating to the voltage given in the question. So we have VRMS is equals to IRMS. However, since the opposition here is through the impedance, which is the total opposition of the component, therefore we will write the term Z here to substitute the resistance in the Ohm's law. Okay, so for that we must first find the impedance in order to deduce our IRMS. So the impedance here has a general equation such as R square plus XL minus XC square square root, where the R here is the resistance, the XL is the reactant of the inductance, and the Xc is the reactant of the capacitance, which is known as inductive reactant and also capacitive reactant respectively. However, our circuit is only made up of the resistor and inductor. We do not have any term or any component related to the capacitor. Therefore, the reactant of the capacitance becomes 0 here. Okay, so the value of the resistance is given in the question. However, we do not know the XL to find the impedance. So, we must first find the XL. So, the equation to find XL is given such as omega L, where omega is equals to 2 pi f L. We have the value of frequency such as 25 Hz, and the inductance is also given in the question. So we can now press our calculator. We will get our XL as 21.99 ohm. Now I can substitute this into the impedance equation, where we have 12 square plus 21.99 square. Remember to square your terms here and square root them, and we'll get our impedance. The total opposition in this circuit is such as 25.05 ohm. Next, we are going to proceed with our IRMS. Rearranging the equation, IRMS is equals to VRMS over Z. We'll have VRMS such as 110 given in the question. Impedance we have deduced, and we'll get our IRMS such as 4.39 ampere. Okay, so the important thing here is to identify the type of circuit before we find the IRMS, as the equation here for the opposition involve the type of the circuit. If it's a pure resistor, our equation is just the basic Ohm's law, V is equals to IR. However, since it is a combination of resistor with another component who can oppose the flow of current using the reactant here, we must consider the total opposition, therefore it becomes impedance. Okay, so we must first find the impedance and then we can deduce our IRMS. Okay, next we're going to look at the question 2 here, where we have to calculate and label the phase angle in a phasor diagram to show the phase relationship between the source voltage and the current. So basically, we are required to find the value of the phase angle. Phase angle here refers to the phi, and also to label this phase angle in a phasor diagram. Okay, so we have to sketch a phasor diagram to show the angle phi, where we can show the relationship between the voltage and also current. So there are two part of question here. So we are going to first start here with the equation of the phase angle. Equation for the phase angle given such as phi is equals to shift tangent XL minus XC over R. This is the equation that we have in our syllabus and also in the list of formula. Alright, so before we substitute all the information here to find our phi, we must first understand, when you have combination of circuit where you have more than two components, what is going to happen is that we will have to find the phi here for the source voltage and also current, no longer between the voltage across a particular component to the current. For an example, we have for pure resistor, the voltage across the resistor is in phase with the current. Okay, they are in phase. So the phasor diagram here shows there is no phase angle, which means they are in phase lah. The current and also the voltage across resistance, they are going to rotate in anti-clockwise direction at the same angular speed. Okay, no one is going to lead anyone here, which means that when the voltage reaches the maximum volt, the current will also reach the maximum current at the same time. However, for a capacitor circuit which has a capacitor component, we will have the current leading the voltage across the capacitor. This is for pure capacitor, where we can see that the current leads the voltage with phase angle of 90 degree. And for pure inductor, we will have the current is lagging the voltage across the inductor by 90 degree as well. So when we combine all these three into one circuit, we will have the resistor, inductor and also capacitor in one circuit. Therefore, we will have voltage across resistor, voltage across inductor and voltage across capacitor. Thus, our phasor diagram will be something like this, where we will have the current, voltage across the resistor, voltage across the inductor and also voltage across the capacitor. Therefore, to find the phase angle now for a combination of circuit, we have to consider all the voltage in the circuit. As we can see, we have voltage in the circuit across different components. Therefore, we have to use the resultant method to find our voltage across the circuit. To answer our question here, we are going to compare our question given here with the general combination circuit. For general combination, we have resistor, inductor and capacitor, whereas in our question we only have RL circuit. Therefore, we are going to eliminate all the term of the capacitor in the circuit. So we are left with VR and also VL in our circuit. So we no longer have the term capacitor in the circuit. So with the phasor diagram that we have here for the voltage and the current, we can deduce that the resultant voltage for the inductor and also the resistor is going to be somewhere here, where this is the voltage of the source and this is our current. So from here we can deduce that we have voltage leading the current by V, and we are required to find what is the value of the V here. According to the phasor diagram that we have obtained here, our V here will be shift tangent, where we have VL along the y-axis divided by VR along the x-axis, and we know that voltage here is the current multiplied with the opposition. Therefore, as we can see here, the current that come out from the power supply, which is the IRMS, is going to pass through the resistor and inductor. Therefore, they have the same current here. So we can cancel this. So we'll end up with the equation such as shift tangent XL over resistance, which is actually the same equation as we have here, where, as we know, this is the general equation, and since we do not have any term of the capacitor in the circuit, so this XC becomes 0. So our equation is left with shift tangent XL over R, which is the similar as whatever we have derived from the phasor diagram here. So now, to answer the question, we are going to substitute the values into the equation so that we can find our phi here. So the phi here is shift tangent XL we have already found, which is 21.99 ohm divided by the resistance is 12. And then you press your calculator, will end up with 61.4 degree. So this is the phase angle. So now we are going to label the phase angle in the phasor diagram, where we need to show our phasor diagram consisting of the source voltage and the current only. Therefore, the phasor diagram for this question will be the resultant V, which is the source voltage, and the current. which is the I here. Therefore, the phi here is 61.4 degree. So we have already calculated the phase angle and we have already labeled our phasor diagram, and the relationship between the V and I can be seen clearly in the phasor diagram, where the V leads I by 61.4 degree. Okay, the last part of question 1b here is to calculate the average power dissipated in the coil. Okay, so to find the average power dissipated in the coil, we must first understand power can only be dissipated across resistor. Then know the general equation for power is given such as P average is equals to IV. Okay, this is the general equation that we have studied in chapter 3 or in our previous knowledge during SPM. Okay, so since we are using P average here, the I here is the IRMS, and as I've mentioned earlier, the power can only be dissipated across the resistor. The other components such as the inductor or even the capacitor, they cannot dissipate the power. Therefore, the voltage here is across the resistor only. So it is the voltage across resistor here. Alright, however, in our question, we have not yet found the V across the resistor. So according to the phasor diagram that we have for this question here, we have voltage across resistance and also voltage across inductor, where the resultant voltage is somewhere here, which we have already found in our previous question with a phase angle of 61.4 degree basically. Okay, as you can see here, the voltage across resistor is along the x-axis, is along the x-axis. As you can see, we know the value of V RMS, V total, we know the phase angle, and to find the VR here, we have opposite, adjacent and hypotenuse. So involving the x component and also the resultant, we will have cos phi is equals to adjacent over hypotenuse, which is the V total. Okay, so when we rearrange, we get V across resistor is basically the VRMS, V total, cos phi. So the voltage across resistor can be substituted such as V RMS cos phi. The V here are all the root mean square voltage here. It is all the root mean square voltage. It's just that we are not writing them here to make things so much simpler lah. Okay, so now we know the value of IRMS. We have already found in the previous question. We have the VRMS given in the question, and we also know the phase angle. We can simply substitute our values here. 110 cos 61.4 degree. So we will get 231.16 watt. Okay, we can also use this equation immediately, but you have to find your V across resistance first, where V across resistance is going to become IRMS multiplied with the resistance, where we also have both these values. It's just that to emphasize on this equation is because in our list of formula in the exam and also in our syllabus, we have deduced that the P average dissipated in the coil is IRMS V RMS cos phi.